Turning points or stationary points are points on a curve where the gradient is 0. Now we test stationarity using the 3 points that we have here. But if we expect a local maximum point, then the second derivative of that equation should be negative. And if the second derivative is positive, then it means that's a local minimum point. But if it's a point of inflection, then the second derivative is supposed to be 0 or undefined, meaning infinity. For example, we are supposed to identify the nature of the turning points of this curve here. So the first thing we do is to find the first derivative of that curve. So we shall say dy over dx is equal to, we bring this 3 multiplied by it here, we will have 6x, reduce 1 from the power, that will be squared. So we have 6x squared minus, bring this 2 here, you get 2 times 5 giving us 10, x raised to power 1 plus 4, and that is the first derivative. Now at turning points, the first derivative is supposed to be 0. The value of the first derivative is supposed to be 0. So for that reason, then we equate this to 0. So we shall say at turning points, the value of this equation should be equal to 0. So this is giving us a quadratic equation which we need to solve for x. We can use many formula to get the values of x, but I've decided to use factorization method. So we look for 2 points, 2 values whose product is the value you get when you multiply 6 and 4, that is 24, and the sum should be negative 10. So that value, or those values, are supposed to be negative 6 and negative 4, or you can say it's negative 4 and negative 6. Negative 4 times negative 6 gives us 24. Negative 4 plus negative 6 gives us negative 10. So we shall expand this equation here, this quadratic equation, and specifically the middle term or the second term, write it in form of this so that we can get the factors. So we shall have 6x squared minus 4x minus 6x plus 4 is equal to 0. Then, having gotten that, take these first two, consider these first two and see whether there is a common factor. We can factor out 2 and x. So 6x squared divided by 2x gives us 3x. So we shall have into 3x minus 4x divided by 2x gives us 2. And then this one will give us minus. Then the factor that you can get out here is 2. So bring 2 out. Then negative 6x divided by negative 2 gives us 3x. Then plus 4 divided by negative 2 gives us negative 2. So that one is equal to 0. You can see what is in the bracket is identical. So you can form a bracket with these factors. So we shall have 2x minus 2 as one of the contents of the bracket, and one of these. We equate it to 0. So at this point, it means either this one is equal to 0 or this one is equal to 0. Now we start with this first case where 2x minus 2, that is this factor here, is equal to 0. Take negative 2 outside the equal, across the equal sign, so we shall have 2x being equal to 0 plus 2, because negative 2, when it crosses equal signs, it changes to plus 2. But if this is the case, then we shall take negative 2 across so that we have 3x being equal to 0 plus 2. Now, this simplifies to 2x being equal to 2, and then this one, 3x is equal to 2. We want x, so we divide both sides of this equation by 2. And for this one, we divide both sides by 3. So that means this gives us x is equal to 1, and this one gives us x is equal to 2/3. Now, these are the x coordinates of the points where we have stationary points. But remember, we want points. We want a coordinate. We want a coordinate, meaning it should have the x and y coordinate. So we should look for the y coordinates for each of these to get the point. So we shall say when x is equal to 1, then the y coordinate will be, you take this equation that we are given, this equation we have up here, substitute x with 1 so that it can help you get the value of y. And that's the same thing we shall do when we shall be getting the y coordinate for x is equal to 2/3. So for this first one, we shall say y will be equal to, this is the equation that I've just pointed up here. So substitute these ones with 1, so we shall have 2 into 1 cubed minus 5 into 1 squared plus 4 into 1, then plus 2. And when you simplify this, it gives you 2 minus 5 plus 4 plus 2, which gives you 3. So the y coordinate for this x coordinate, the partner y coordinate is 3. Therefore, we can say the point is 1, 3. Then we come to this one, we also find its corresponding y coordinate. So we shall say when x is 2/3, the y coordinate will be given by the same formula here. So we shall have 2 into 2/3 cubed minus 5 into 2/3 squared plus 4 into 2/3 plus 2. And if you do that, you will get it simplifying to 2 into 2 cubed is 8 over 3 cubed is 27 minus 5 into 2 squared is 4, 3 squared is 9, so 4 over 9, then plus 4 times 2 gives us 8 over 3, then plus 2. If you simplify that, you will get it being 3.037. So this means the point is 2 over 3, comma 3.037. You can decide to write both of them in a decimal form or a fraction form, there's no problem. So that is the other point where we expect the turning point. We have identified the turning points, but we have not established their nature. In other words, we don't know whether it's a local maximum, local minimum, or a point of inflection. The first derivative we had is this one. So for us to get the second derivative, we have to differentiate this one more step. So that we shall say d squared y over dx squared, that is the second derivative, is equal to the derivative of this first derivative that we have here. So if we differentiate this, you will get 12x minus 10. So that's our d squared y over dx squared. So this is what we shall use in inspecting. The first point we got, where station point is 0.13. So the x coordinate is 1. Take that x coordinate and say when x is equal to 1, the second derivative will be, substitute this 1 in this x, we shall have 12 into 1 minus 10, and that gives us 2. That's 12 minus 10, giving us 2. You notice that this 2 is a positive number. And then we said up here, when we differentiate twice, if we differentiate twice and get a positive value for the second derivative, it means that's a local minimum point. So that means that whatever we have found here is a local minimum point. In other words, 0.13, which we have tested here, and given us a positive value, is a local minimum point. Then we come to the second point we had. The second point is this one. The x coordinate is 2, 3. 2 over 3. Substitute it here also and get the value. So when x is 2 over 3, we shall have d squared y over dx squared being equal to 12 into 2/3 minus 10. And if you do that, you'll get it giving you 8 minus 10, which is negative 2. we said that if you get a negative value for the second derivative, it means that's a local maximum point. So that means that this point is a local maximum point.